What we're going to look at today then is the idea of solving problems involving circles. So yesterday we looked at our key formulae and those were A equals pi r squared. So area is pi r squared and circumference is pi d. So we're going to be looking at how we apply these to other sorts of problems today. So again, I've put some notes up here just to kind of give you a flavour for the sorts of things that you need to do to help you tackle these problems. So the first thing you want to do is look at the different shapes that you've got and look at the problem, obviously try and figure out what the problem's asking you for. But more importantly, see if there's anything you can do to the shape to kind of cut it up into different rectangles or triangles or circles or semicircles or fractions of circles. Basically looking to use the formula that you know and then figure them out. If it's perimeter, then you need to walk around the outside of the shape. If it's area, then you need to find the space inside the shape. Or if you need to add some extra measurements on the diagram to help you have all the measurements required, then again, that's a really good technique to use. So we're going to work our way through two problems. So we've got the shaded area here, and we're going to find the area and perimeter for it. And then we've got this funny looking shaded area here, which we're going to find the shaded area for. So looking at this first problem then, let's just think about all the things that we've got. So we've got a rectangle, and so if we want to find the area, we're going to find the area of the rectangle, and then I think what we're going to do is add on the area of the circle. So my diagram is just visualising the calculation I'm doing. So I need the area of the rectangle and I need half a circle because we've got the semicircle on the end there. So to find the area of a rectangle, then we use our formula length times width. And to find the area of half a circle, we're just going to do a half times pi r squared. So that's our formula for the area of a circle. And we're timesing it by a half or dividing it by 2, which is the same thing, because we only want half of the area of a circle. So let's substitute in the values that we know on our next line. So looking at the rectangle, we've got a length of 12 and a width of 6. So that means we're going to do 12 times 6. And if we're trying to find the area of the semicircle, we need to know what the radius is of this semicircle. So if we look, the length from the top of the bottom of the semicircle, from the top to the bottom, sorry, is 6 centimetres. So I believe that the radius there is 3 centimetres. So if I go back to my formulae, I did the 12 times 6 for the area of the rectangle. I'm now going to do a half times pi times 3 squared. Okay. Now we can leave our answer as an exact value in terms of pi, or we can give it as a decimal. At this point here though, I'm just going to chuck all that into my calculator and give you the answer as a decimal. So 12 times 6 plus a half times pi times 3 squared. And I get a value for that to be 86.1. And I'm going to give it to one decimal place. So I'm going to state that. And that's centimetres squared because that's the area. And there we go. So that's our exact area to one decimal place of this shaded shape. The next thing we're going to do is do the perimeter. Now the perimeter is if you're walking around the whole outside of the shape. So I'm going to add some more measurements onto this now. The first measurement I'm going to add on is this top length of the rectangle. Now if the bottom's 12, I believe the top is 12 as well. And so if I was to walk around the outside of the shape, I'm going to start in this corner here. You can start anywhere as long as you get back to that same point. And I'm just going to add on the measurements that I get. So I'm going to do 12 plus the 6 plus the 12. So I've gone across, up and then back across. Notice how I don't need to do this second measurement of width from the rectangle. That's because that's an internal measurement of length. But what I do need to do is I need to measure this distance around the outside of the semicircle. So what I think we need there is half of the circumference, because the circumference would be as if there was a whole circle and we just need half of that. And we know what the formula for circumference of a circle is. It's pi d. So on my diagram now, I'm just going to do a half times pi times the diameter. Now this circle had a radius of 3 and the diameter is double the radius. So I believe that double 3 would give us 6. And then if we just think about it, well, a half times 6, a half of 6 is 3. So that for me is just 3 pi. So the distance around this arc here, this semicircle, is 3 pi. So I'm now going to add that on the end of my calculation for perimeter. And that is going to take me all the way back round to that starting point there. And so that can now be simplified to say that the perimeter is 12, add 12, which is 24, add 6 is 30, so 30 plus 3 pi. And again, we can leave our answer like that, that's an exact answer. Or if you want to give it as 1 decimal place answer, we just pop that into our calculator, and I get 39.4 centimetres to 1 decimal place. And again, note that because it's a perimeter, it's a measurement of length, so we're going to use centimetres to measure our length. Okay, now these are really tricky problems, these, so if you're keeping up, that is brilliant. This final one then, if you look, we're trying to find these shaded regions here. I apologise for the poor diagram, it's the best I could do really. And what we're going to have to do here is think about our problem solving skills here. Now, I believe to find all these shaded sections here, we need to do the area of the rectangle, take away 3 circles, because we've got 1, 2, 3. So that's going to be like our method, our problem solving method. We've got the area of the rectangle and we've got 3 circles. So what we now need to do is think about how we can find some missing measurements. Now if you look, 3 circles of all equal size, so for me, I think that the diameter of each of these would be 4 centimetres. Diameter of 4, 8, and diameter again of 4 makes 12. Which means that that measurement there, because a circle has the same diameter if you draw a line from one side to the other through the centre at any point, would also be 4 centimetres. And again, if we want to kind of extend that a little bit more, I would say that the radius is 2 centimetres. And the reason it's 2 centimetres is because it's half of this diameter. So I think we've now got all of our key measurements on our diagram, which allow us to think about finishing this problem off. So let's just think about how we find the area of the shapes that we've got. We've got 12 by 4, that's the area of the rectangle. And I believe that's 48. 12 4 is 48. And I've got to take away 3 times the area of a circle. So that's pi times our radius squared. And our radius squared, in this case, is 2 squared. So again, what I'm going to do is just write above each of these the formulas I've used. So I've used length times width for my rectangle, and I've used pi r squared times by 3 for my circle. Sorry, it's a bit messy. Let's try that again. Minus 3 times pi r squared. And again, if we calculate this, again, thinking about BIDMAS, we do squaring first. 2 squared is 4, times 3 is 12. So we're going to take away 12 lots of pi. And that's our exact answer. And if we want to give it to 1 decimal place, we're just going to do 48, take away 12 times pi, and that's going to give us 10.3 to 1 decimal place. And that's centimetres squared because it's space, it's area. So kind of a reminder then of the key principles that we're looking at today. If you're finding what we call a composite area, which is like an area of combined shapes or sections, look to split the shape up into bits that you know you can work with. Triangles, rectangles, even trapeziums, quite difficult, but we can still calculate with them. And always add extra measurements on the diagram to help you with your calculations. State your formulae, substitute in your values, and then round at the end and state what you've rounded to. Okay, good luck.